Hey, isn't that Roman?
Oh yeah, actually I heard she got a 3D printer. Let's go ask her about it.
Hey guys, what's up?
Hey Roman, I heard you got a 3D printer. Are you excited?
Not really. It's mostly my dad's, and I don't really know a lot about it.
Aren't all printers 3D though? I mean, they're all two-dimensional.
No. Do you not know what a 3D printer is? They're the printers of the future.
But what's the difference between a regular printer and a 3D printer?
Well, first of all, 3D printers are a lot bigger and much more expensive than regular printers. The smallest one can only print small designs, but the bigger they get, the larger the object they can print.
Okay, that makes sense, but I don't really understand it.
3D printing is the process of making a 3D object. First, there's the modeling phase, then the printing phase, then the finishing of the product. Pretty simple, right?
I still don't get it.
Yeah, it's still unclear.
You know what? I did a group project on 3D printing last year. I can go show you and I'm sure you'll understand after.
Sounds good.
Alright.
So show us.
Okay. In the simplest of terms, 3D printing is the making of a three-dimensional object by using multiple layers of a thin material. Keeping things simple for now, there are two approaches to this kind of printing. First, we have direct printing. Also known as straightforward printing, it employs the same jet techniques as 2D printers do, but their moving nozzles spit out waxes and plastic polymers instead of inks, forming lots of layers. On the other side of things, there is binder printing, which forms layers using a fluid made up of dry powder with dissolved glue or another binder. This method takes 2 passes to form each layer, taking more time. Let's go more into depth of 3D printing.
Additive manufacturing is a type of manufacturing that describes 3D objects being created by adding layer upon layer of material. You can compare this to how, in caves, dripping water over time creates layers of mineral deposits, which will eventually turn into stalagmites. There are 3 widely used technologies for 3D printing. There is selective laser sintering, shortened to SLS, fused deposition modeling, shortened to FDM, and stereolithography, shortened to SLA. They differ in the way layers are used to create objects. SLS uses powdered materials that are fused together by lasers, creating a solid object. SLS is the least user-friendly model and is primarily used by professional companies. FDM, however, is the most user-friendly, heating and melting materials through a nozzle and cooling after it's been printed into a layer, building from the bottom up. The last technique, SLA, uses an ultraviolet laser to solidify a resin to form a single 2D layer formed by polymers.
There are 6 main steps involved in the process of printing a 3D object. First, you must create a computer-aided design of the object you would like to be printed. Next, that file must be converted to standard tessellation language, also known as STL, in order to be read properly by the 3D printer. Next, the STL file must be copied over to the computer that controls the 3D printer. Here, it can designate what size it would like the object to be, along with other characteristics. Before you begin to 3D print, depending on the machine, you may have to refill the materials that will be used to make the object. 3D printing can use plastics, metals, and many other materials. Finally, there is the building stage, which requires much patience. Here is where it will either use FDM, SLS, or SLA to build the object. For example, if FDM is used, the machine will repeatedly orient itself over the same area, building the object from the bottom up. Think of it as a hot glue gun. A solid material is put in one end and gets pushed out through a hot nozzle on the other, melting it into layers, soon returning to a solid state when it hits a certain temperature. The last step to be considered is after the object is done being printed, removing any excess material or powder, and voila, you have now created your own 3D printed object from scratch. Now, let's dive into the history behind this invention and how it came to be.
In 1980, the first patent for 3D printing was filed by Dr. Hideo Kodama. He started with rapid prototyping and described a layer-by-layer approach to manufacturing. In 1981, Dr. Kodama published for the first time the manufacturing of a printed solid model. However, he did not submit the patent requirements before the deadline for his invention of the photosensitive resin, which is used in stereolithography, also known as SLA. The next group to take on 3D printing were French engineers, who lacked business perspective. The first patent for SLA was done so by Charles Hull in 1986. After SLA came selective laser sintering and fused deposition modeling, shortened to SLS and FDM respectively. SLS technology was brought about in 1988 by Carl Deckard, and FDM was patented in 1988 by Scott Crump. However, the two main techniques used in 3D printing are SLA and FDM.
Additive manufacturing first started being used in rapid prototyping during the late 1980s. Prototypes are created so that producers could analyze the designs of their products to see if they worked or if there were any flaws. This enabled the producers to save money by viewing the prototype before producing the final product. Producers were able to create more prototypes at a faster pace by using additive manufacturing during the rapid prototyping process. The creators would first design the 3D object using computer-aided design software. Once satisfied, the 3D printer would use that design to see how to actually create the object.
In the 1990s, 3D printers started becoming more popular and useful to different industries across the world. Various techniques started emerging, such as the Z402, which uses starch and plaster-based powder in a water-based liquid binder. Another example is the Arkham MCP, which used selective laser melting, or the Spectrum Z510, which was a high-definition color 3D printer. Medical applications for 3D printing also began in the 1990s. As the years went on, 3D printing began to grow and expand into several industries. In 2009, the FDM patents fell into public domain, which caused more innovation and increased visibility, leading to the creation of the first 3D printed prototype car and the first 3D food printer. As we have seen in the past few years, there have been many improvements with 3D printing technology and its impacts in other industries. Wait, so what does that mean?
Just watch the video, Matusha.
Before 3D printers existed, everybody used 2D or traditional printers. With traditional printers, ink and toner are used to print images and words on paper or similar surfaces. This means that only flat images or hard copies can be printed. They function by scanning an image or any type of document, then using colored ink to copy the image onto a flat surface. Now, with 3D printers, people are not limited to printing only flat images. Instead, they can print 3D objects using raw materials such as thermoplastic, metal, or ceramic.
In terms of pricing, 3D printers are drastically more expensive than traditional printers. 3D printers range from a couple $100 to a couple $1,000. Prices have been trending downward in recent years because of the improvement in technology. A 3D printer a decade ago would have cost approximately $100,000. Nowadays, a basic desktop printer can range from $200 to $900, and a 3D printer can cost from $300 to $1,000. A lower price means greater limitations and a decrease in quality. There are also such things called DIY 3D printer kits, which allow people to build their own 3D printers and can sometimes be cheaper than buying a pre-made 3D printer. The price can range from $200 to $6,000, depending on the materials used to build the printer. While traditional printers are still commonly used in our everyday lives and in our homes, 3D printers are gradually impacting society and businesses around the world and growing in usage and popularity.
The use of 3D printers has become greater over the past couple of years, offering individuals and businesses many more benefits than traditional manufacturing. Firstly, 3D printing is more cost-effective than the traditional manufacturing process. Companies take advantage of the low prototyping price of 3D printing technology by integrating it in their production process. There would also be cuts in labor, as most 3D printers only need one person to submit a design and press a button in order to start the printing process. With the traditional method, employees work in multiple areas in order to complete different parts of the final product.
Secondly, there is minimal risk in creating objects using a 3D printer. With the traditional manufacturing process, creating a product and it not working can be very costly. It could cost firms a lot of money due to the loss of resources and the additional time spent on fixing the item. Even small changes over the course of the production process can be costly in the long run. With 3D printing, however, it would allow the business or individual to print a ready-made, working prototype to test out. If the prototype does end up being successful, then the firm or individual could make bigger investments when creating the final working product.
3D printing is also usually a one-step production process. With 3D printing, the final product is printed in one step in a couple of hours or longer, depending on the size and complexity of the object. This allows businesses to be less dependent on other machines and manufacturing processes, like welding. With traditional manufacturing, the final product may need multiple other parts from other manufacturers in order for it to be created. The time it takes for all the parts to come together to form the final product may take weeks or even months.
The technology is also allowing entrepreneurs to start a business by allowing them to create their product using the 3D printing technology. Entrepreneurs have the ability to create personalized products for consumers, which is becoming more popular today. This is why firms that don't adapt to the world of mass customization are put out of business. Mass customization adds value to the product sold as the personalization of the product creates a unique user experience. For example, Feeds is a company that creates shoes that is custom to the exact size of the wearer's foot. It has been able to do this by using 3D printing technology and by creating a software to custom fit their shoe designs to the consumer's feet.
However, 3D printing technology is not perfect. Although the cost of 3D printers has declined over the years due to the improved technology, the machinery and materials used are still expensive. This is especially true for larger printers, as the larger the 3D printer, the larger an object can be created. But that would be more expensive and would take a lot longer to create.
There are also only certain materials that can be used in the printing process. The most common choice is plastic, as it can be deposited down in melted layers to form the final part. However, plastic may not be that strong and may not be the best suitable for some components. Also, 3D printing cannot compete with how fast products are being made in traditional manufacturing yet. That's why mass production using traditional manufacturing processes are much cheaper than making large batches of objects using 3D printing.
Like any new invention, 3D printing has had drastic effects on the development of society, both good and bad. Beginning with the bad news, 3D printing has made it more difficult to stop the distribution of illegal things, such as working guns. This is happening because these objects exist as computer files first, so there is nothing law enforcement can do before it is actually printed. Another impact on society is the lessening of human interactions, since people can now print what they need from home. This can weaken a community's sense of connectiveness. Along with this innovative technology comes the loss of manufacturing jobs, which has a negative impact on our economy and people's lives if they lose their jobs. As it can be seen, this new technology comes with power and responsibility.
But of course there is a good side to this amazing invention. For one, the environment is being helped, as manufacturing can be done from one place instead of using airplanes, ships, and trucks for shipping. It has also been a great help to the medical industry, printing things for our bodies, such as organs and prosthetics. This will reduce the waiting time for organ transplants, saving multiple lives. The aerospace industry also benefits from 3D printing, using it to make aircraft parts. It has even been used to make a wing of a plane. Linking this back to the environment, the lighter the aircraft, the less fuel it will use, reducing carbon dioxide emissions. Overall, we can see how much of an impact this new invention has had on society, and that there is more room for growth and possibilities for its accomplishments in the near future. So now do you guys understand what 3D printing is?
Oh yeah, it makes so much more sense now. Maybe I'll start using it more than my dad does.
When you print something, could I come over? I would love to see it in action.
Why don't you come over this weekend and maybe we'll all try to print something?
That'd be awesome. Only one though? There's so many things you can print. It'll take me all week to decide.